Right, hello, Discrete Math. I thought I'd make a quick video tutorial since we are going to be having a Chapter 1 exam next class. I want to make sure you're feeling comfortable with the topics that we've looked at most recently. So, if you look at your review sheet, we have a bunch of terms up top that you should probably be familiar with. If you're not familiar with any of these terms, please look back at your notes, look them up. I will be available after school on Monday if you'd like to chat about any of this stuff. So definitely look me up. No problem. This is all stuff that we'll do in class, etc. So I'd like to look at the study guide in particular, the assignment that you're going to be doing for tonight, and I want to kind of elaborate on a few of these problems here. First off, as far as writing things in an alternative method, there are lots of alternative methods. We talked about set builder notation. We also talked about set notation. Big difference being here, set builder notation has the colon. Set notation just lists a bunch of things. All right, so alternative method just pretty much means use the other type. All right, so T such that T is a letter in the word happiness. Another way of writing that would be in set notation, just writing all of the letters that happen to be in the word happiness, but none repeated. So if you look at the cardinal number of this, let's say, I know that's not part of the problem, but if we look at the cardinal number of this, 1, 2, 3, 4, 5, 6, 7, we'd say that this one has 7 elements within this set. Indeed. Next one up, we are already given set notation. We're going to build it in set builder notation. Do notice that it is every letter of the alphabet. So an alternative way of writing this could certainly be saying something like X such that X is a letter of the alphabet. All right, so you were given set notation. We rewrote it in set builder notation. Looking at the next one, Y such that Y is a living person who fought in the Revolutionary War. Unless you've been watching these show alphas recently, you're not going to see any characters who lived since the Revolutionary War. What was Revolutionary War? Several hundred years ago, so nobody's alive. Nobody's alive. So if you want to say that there are no elements, nobody's alive from this time period, I'm just going to say null, or in other words, empty set. You can write it as null or empty set. Both of those are perfectly fine ways of writing it. If you want to use an analogy of that, think of the plastic grocery bag that we had, right? Plastic grocery bag that we had. It currently contains nothing. Contains nothing inside of it. Looking at the next one, explain the difference between the null set, the set of null sets, and the number 0. I'm just going to verbally describe this here. The null set, think of a plastic bag, all right? Plastic bag, it's a container that contains nothing. All right, that's the null set. It's the container that contains nothing. This one, though, this set of null sets, that's going to be a plastic bag that's going to contain a second plastic bag with inside of it. All right, so these are not equal things, certainly. They're different things. This is as if you'd put an empty thing into another empty thing. In the last one here, the number 0, it's a number. It's not even a set. It's a number. It quantifies nothing, but it's a number. It doesn't hold anything like the red empty set. It doesn't hold another thing that holds nothing like the blue set. It literally is nothing. Cardinal numbers, remember cardinal numbers just tell the number of elements in a set. So if it's the number of months in a year, well, there's 12 months in a year, so we'd say that the cardinal number for T is 12. Explain the difference between a set and a proper subset. I think we went over this pretty well in class. A set or a subset is any subset, and then a proper subset is a subset not equal. So I want to relate this to less than and equal to signs. If you have a subset, we write this symbol with with the equal then? It could be potentially equal. So your set might be ABC, let's say. You have the set ABC. That could potentially be a subset of the set BAC. Right? They're equal sets. This is kind of like a less than or equal to sign. They're definitely equal, so that's totally fine. On the other hand, if we have ABC, I'll go and flip over to red instead. If you have set ABC and you want to say proper subset here of set BAC, that is not a true statement because these are equal to each other. It's kind of like saying let's use some numbers. We could say 3 is less than or equal to 3, right? Totally valid thing. We cannot, however, say that 3 is less than 3. That's not a valid thing to say. Subsets work a lot similarly, and proper subsets work really similarly. So that's where the next few problems are going to come into play. Are these numbers a subset of these numbers? Yeah, they are. Every single element in the left one is in the right one. They're set. Excuse me, not they're set. They're okay. Yeah, they're okay. Looking at these other ones, these two are equal to each other. Because it's a proper subset that we're looking for, this is going to be a false statement. Since they are equal, it's kind of like saying 4 is less than 4. 4 is less than 4 is not a true statement. Similar to 2468 is a proper subset of 8462. Not a true statement. Not a true statement. Words in the letter Mary versus Mary. Do notice that this first set would contain the element E. The second set does not contain the element E, right? Because of that, this first set has an element. In fact, it has M, E, R, Y. And this other one has M, A, R, Y. Because this one contains E, the set doesn't. It is not technically a proper subset. It's not a subset at all. This next one up, null set is a subset of 1, 3, 5. I want you to envision the plastic bags here when we think about that. Null set is a subset of 1, 3, 5. Null set, right here, it's kind of like having a single plastic bag with nothing in it. This set, it's kind of like having a plastic bag with the numbers 1, 3, and 5 located in it. Is it true that every element in this set is in this set? Well, if you take anything out of this first one, of which there's nothing, yes, absolutely everything in this one exists in this one as well. We'd say that it's a subset. 11, it would be true if we had an equal sign. Yes, null set is a subset of null set, but null set is not a proper subset of itself. That goes back to the explanation with this example up here. If they're equal, they're not a proper subset. Last couple ones down here are the following sets equivalent to each other. Remember, the word equivalent means same size, same cardinal number. So it looks like this first set, 1, 2, 3, 4, 5 elements. This one has 1, 2, 3, 5 elements. Heck yes, those are going to be equivalent to one another. How many subsets are there of the set K? K is equal to blah, blah, blah. Remember, each number can be on or off. There's two options. I can either contain a subset that has a 1 or not. It might contain a 2, it might not. It might contain a 3, it might not. It might contain a 4, it might not, etc. So there's two options for including the number 1, two options for including number 2, two options for including number 3, two options for including number 4, etc. You're going to multiply 2 by itself 10 times. In other words, 2 to the 10th power, which if you've been doing any computer science recently, it is 1024. 1024. Looking at some Venn diagrams. Venn diagrams here. Set A intersect B. Remember, I remember this as if it looks like an N, it's an intersect. If it looks like a U, it's a union. A intersect B. If this is A over here, and this is set B over here, A intersect B is going to be this stuff right on the middle. If you look at the next set here, let's see here, we have 3 sets, A, B, and C. Let me go ahead and label those. A, B, and C. I'm going to first think about this portion right here, B union C. If I wanted to label everything that's B union C, it's going to be anything that's in B and anything that's in C. All right, that's going to include absolutely everything in B, everything in C. Now, if I say A minus that, that's going to be all of A. Subtract anything that exists in this portion. All right, so it's going to be all of A out here, but it won't include anything that it had to do with the B union C set. So nothing in this portion, nothing in this portion, nothing in that portion. So we have just set A that doesn't intersect with anything else. Isn't the union of anything else. Last bit up here, practice a survey problem. I strongly recommend you practice a survey problem, so I'm going to switch over to the homework that you did for chapter 1.6. That's the survey problems assignment, and I figure I'll just go ahead and do the last problem. Why not? Let's go and look at this last problem here. I don't know if any of you are even old enough to remember the Three Stooges, but the Three Stooges are hilarious. Moe, Larry, and Curly, they all have their interesting personalities. Anywho, suppose we're doing a film studies class. Maybe if you're taking film studies, you've heard of them. We're going to have 3 sets, Moe, Larry, and Curly. I'm going to have set Moe up here. I'm going to have set Larry over here. And I'm going to have set Curly over here. We have Curly, Larry, and Moe. Now there's several questions being asked. Let's look at the clues that we're given. We're given that 51 admire Moe. In other words, in all of this space, 51 people admire Moe. We don't know how many is going to fit into each section, so we need to leave that clue alone. Same with the 49 admire Larry. Okay, granted there's 49 in all of these portions, but we don't know how much is in each portion. We can ignore it. Same with Curly. 34 admire Moe and Larry. 34 fit inside this portion, but still that's 2 different sections. We don't know how much is in each one. So these and statement ones, we're going to have to ignore the and statement ones for a moment. By the way, I know I missed something right here. I'm going to go and make a green box surrounding this entire thing for the universal set. Because it looks like one person admires none of the Three Stooges. So I'm going to put that person out here right away. There's one person that admires none of them. That clue's done. 24 admire all 3 of them. I'm going to go ahead and put 24 then right in the middle. They admire all 3 of them. Now that we have that information, I can start doing some of the and statements. 36 admire Moe and Curly. Moe and Curly, that's all this space right here. We already have 24 here. We know 36 total. Well, doing some quick arithmetic, the 36 minus the 24 is in fact a 12. So we can conclude that 12 people admire Moe and Curly, but not Larry. Poor Larry. That clue's done. We're just going to knock out these clues backwards. 32 people admire Larry and Curly. Larry and Curly is going to be this section right in here. 24 of them or 32 of them total. 24 of them fit in there, so that means there's another 8 left. We are cranking through these. Got done with that one. 34 total. That means that there's 10 left that admire Moe and Larry. That clue's taken care of. 60 admire Curly. Let's do some math here. There needs to be 60 that fits in this entire structure. 60 that fits there. We already have 12 plus 24 is a 36. plus an 8 is going to be a 36 plus an 8. I don't have a calculator. You shouldn't use this either because that is a 44. 44, we have another 16 to get up to 60. Let's make sure I did that mental math right real quick here. 12 plus an 8 is a 20. Cool. 24 plus a 16 is a 40. 40 plus the 20 is 60. Yes, Curly is set. We are done with Curly. Larry, oh no, we've got some numbers that don't have zeros in it. Let's do some more mental math and put me on the spot here. Larry has 49 admirers. Let's see, total of 49, subtract 10 is a 39, subtract an 8 is 31, subtract 24, that would be an 11 minus another 4, 10, 7. 7 admire only Larry. Larry's kind of a doofus anyways. Who cares? Poor Larry. Last one up here, we have 51 admiring Mo. Let's go ahead and do another big computation here. 12 plus 24 is a 36, plus 10 is a 46. 46 to get up to 51 is 5 left. We have 5 remaining. Wow, Mo's even more unpopular than Larry and Curly. Bummer. It doesn't, there isn't an immediate showing of that because it shows like, it says Larry is less admired than Mo, but more people like only Larry than only Mo. That's kind of interesting to me. Oh well, anywho, how many people were surveyed? That's a pretty easy problem. Go ahead and just add all of these numbers up. How many people were surveyed? We have another one putting me on the spot. We have 20. And, well, Curly was a total of 60, 70, 82, 83. It looks like 83 people in total were surveyed. How many admire Curly but not Larry nor Mo? Curly looks like 16 people admire only Curly. How many people admire Larry or Curly? Larry or Curly, that's going to be 20, 36, well, that's 60 in there, 70, 77 admire one or the others. How many admire exactly one of the Stooges? That'd be the 16 plus the 5 plus the 7. Same thing as 16 plus a 13. 29? 29? Man, I know somebody's going to call me out in class on getting one of these wrong. I am positive of that if you're doing this on your calculator at home. Anywho, how many admire exactly 2 of the Stooges? Goodness, exactly 2 of the Stooges. Oh, we just need to add these 3 numbers, that 10, the 12, and the 8. 12 plus an 8 is a 20, plus a 10 is a 30. Looks like we have 30 total that admire exactly 2 of them. Neat. Well, we did this problem. That's a survey problem. We're done. Again, if you have any questions, please feel free to swing by Monday after school. I am totally fine chatting with you on Monday after school. Yeah, study up for that exam. If you haven't signed up for those history presentations, please do so soon. Have a delightful day. Bye-bye.